LabelUp accelerates innovation in the realm of image and video data labeling, offering a solution that is not only efficient and accurate, but also open source and portable. This tool is specifically tailored for the rigorous requirements of AI model preparation, ensuring an optimal blend of speed, precision, and scalability. With its capacity for on-premises and air-gapped deployments, LabelUp addresses critical concerns around sensitive data, making it a versatile and secure choice for diverse environments. Its modular design and integration of advanced vision transformer models elevates the data labeling process to new heights, redefining the standards for operational AI model development across government and research sectors. Now, let's jump into a demo. So here we see the LabelUp landing page. We see a list of projects. For this demo, we're gonna start off with a simple project where we wanna label some buses to eventually train an AI and machine learning object detection model. We want these to be segmentation mask labels. I'm gonna go ahead and click into my buses project here. On this screen, we'll see our labeling interface. This is a modular design, so for this demo, we're using Label Studio, but this could easily be LabelBox or any preference of labeling interface that you would want to swap in here. So you also see some images of buses down below. These are some representative images of buses that I think accurately display the object that I'm trying to label. So I'm going to click into one of them here. We can go through our traditional labeling process. If you were to stand up Label Studio just out of the box, you would have this cursor available that would color in your object. You can obviously see this is very time consuming and also very prone to human error. So how can we accelerate this process? Well, using advanced vision transformer technology, we can simply place one key point on our object of interest and have the backend model automatically segment out our mask for our object of interest. I'm going to go ahead and keep this one. I'll submit it, and I'll do one more here. Again, one click, one key point, and successfully able to segment out our object of interest. I'll submit that, and then go to the next step of LabelUp. So this is where I'm going to choose my prompt images to auto-label the rest of my unlabeled data set. So you can see I'm pointing to a file store here. This can be a local file source or cloud, remote storage, whatever it may be. I'm going to go ahead and choose my two prompt images here. And I'm going to have it label 50 of these unlabeled images in my data store. I'll go ahead and submit this. Now that our 50 images are finished processing, we get back to our landing page and we can view sample results of this auto labeling process. I'll click into this. I want to view all of our 50 images. And now you can see that buses that previously were unlabeled in our source data set now have correct segmentation labels on them. This is all just using the two prompt images that we provided the auto labeling model. We even throw some images in there to try to trick it. For example, this image of a zebra, it doesn't have a bus in it. The auto labeling model doesn't try to force a label into this image where there's clearly not a bus. And then a more difficult example of this bus that's obscured by a horse and carriage, it's successfully able to segment out the image of that bus. Now back on our landing page, let's take a look at a more difficult example of this auto labeling model in work. So here, I went through the same process. I provided the auto labeling model with several prompts of overhead imagery of aircraft. You can see here, I have previously unlabeled images of aircraft, and the model is successfully able to identify most, if not all, of the aircraft in the images. Your next question might be, how do I select the best prompt images for my auto labeling model? Well, LabelUp includes a data exploratory tool. So here you see our data exploratory tool, part of LabelUp. You can see I've selected a data set, the ImageNet data set over here to the left. Below this, you see a 3D representation of every image in that data set, reduced down to a 3-dimensional space. So what can I do with this? Well, I can see where the features of all of my images land in 3-dimensional space, and then I can search this via text. So for this demo, I want to search for a green lizard, specifically green lizards on a tree. Go ahead and hit search. I get back some matching images here. So how does this help me select the best prompt images for my auto labeling model? I can go ahead and show the matching images only over here. I can see there's 2 pretty distinct clusters of images that match my text prompt. So if this is the thing that I want to label, now I can go select prompt images across both of these clusters equally to get an accurate feature space for my labeling process. So as you can see, with LabelUp, we provide data scientists with a tool to accelerate image and video data labeling tasks. In a landscape where the mastery of AI ML is crucial for success, LabelUp emerges as a key enabler, offering a technology that accelerates the data labeling process with advancements in efficiency and accuracy. Its open source framework and the ability for on-premises or air-gapped deployment accentuate its appeal, especially for applications requiring stringent data security measures. For the Department of Defense and others operating in environments where data security is paramount, LabelUp represents a leap forward into a future of secure, efficient, and cost-effective AI ML development. If you're interested in learning more, please request a demo by contacting MetroStar.